All right, so hi, I'm Kristaps Bras from UgCS. I'm a systems engineer here, and I'm joined by Tom Altmaier from Airborne Response. And so maybe let's, before we dive into the webinar itself, maybe let's start with introduction. So maybe Tom, you can kind of take us through a bit how this whole thing started and how we started working with you guys and with search and rescue operations.
Hi, Kristaps. Thank you very much. My name is Tom Altmaier. I'm currently the chief pilot with Airborne Response, and I also fly the Miami Dade Fire Rescue. We're one of the largest fire departments in the Southeast United States. I fly their helicopter. I've been flying search and rescue helicopters for, actually this month is my 26-year anniversary. So flying search and rescue helicopters for 26 years. And prior to that, I was also in the Air Force, U.S. Air Force, flying Air Force Rescue. Basically, with Airborne Response, we've been doing a lot of training, and we've been training in cooperation with a large university in the Southeast U.S. And they do a lot of disaster response, and that's Airborne Response's focus is disaster response also. So I was looking for a mission planning software platform that would be able to do search patterns, creeping line, expanding square, and unfortunately, most of the mission planning software out there is pretty much written specifically for DJI. And I was looking for a more platform agnostic software. And that's how I came across UgCS. UgCS it writes for everybody. ArduPilot, DJI, I mean, you name it, UgCS supports that hardware. So I dug deep into the UgCS mission planning capabilities. Unfortunately, there was, you had to develop your own search patterns. In other words, based on the search height, you had to use a little bit of, or we had to use a little bit of trigonometry and figure out what the best track spacing was that you would have completely overlapping coverage of the search area. And that could be kind of cumbersome when it comes to time critical response. So I approached, or actually we, Airborne Response, approached UgCS at the Exponential Conference in Denver of this year, back in May, and we developed a partnership and said, hey, let's get together and develop probably the first search and rescue capabilities in a mission planning software package. And we focused on the creeping line and the expanding square. Why the creeping line and the expanding square? Well, basically, excuse me, the expanding square is
I'm sorry, Tom, maybe before we kind of comment that, maybe I can actually now kind of open just UgCS up. So it's probably some people are not really familiar with these search patterns, just to kind of, add some like visual aspect of,
sure.
add some more understanding to that. So, okay, let me quickly try and share the screen. Okay, so I guess now you should be able to see UgCS screen. Right, can you see the square?
Yes.
All right, perfect. So now I have two missions here. One is the expanding square, this one, and the other one is the creeping line. So let me show this.
If you want to just Kristaps, just hold it on the expanding square for a second.
Yeah.
I'll discuss the expanding square real quick and why you would use that.
Okay. Let me show it again.
All right. So basically, if you take a look at that expanding square, you can use that when you're searching for somebody that has basically they can move in any direction. So you get a last known position, and that person you're looking for could move north, south, east, west. There's nothing limiting their direction. So you just start in the center, that last known position, you just expand out. That's when you would use the expanding square search pattern.
Right, so you use the expanding square when you have one kind of central position and you have basically no clue in which direction that person might have gone, right?
Exactly, and they could move, and there's no limitation. There's no geographic boundary. They can move in any direction they want. And then if you want to go over to the creeping line, we could discuss a little bit about why we would use a creeping line.
Yeah, 1 second. Yep.
All right, so the creeping line actually works very well out over water when there's a current or a drift. So you set up the search area like Kristaps is doing, and then you would tell it which way you want to creep. So say there's a current moving north. If north is up on Kristaps' screen, you're going to have that creeping line moving north just as it is. So you see multiple track spacing, but each leg of the route is moving north. So a creeping line is great when there's boundaries or when there's a natural flow, maybe a river, over a river where a river is flowing in a certain direction. You would start from the last known position and then creep in the direction of that river current.
Right. So since I'm not like a search and rescue guy myself, so I have a question. Like, let's say in typical kind of scenarios like this, when you're using drones, what's the typical sort of altitude as well as the search radius that you usually do with drones? Because it's obvious that manned aircraft they can fly for a lot longer time period than drones.
Well, that's a really good question, and it depends. The search altitude really depends on your hazards in the area. So when you get to the search location, you'll do a scene size up and you'll do a risk assessment. You'll take a look at any hazards. And typically you're gonna, and I would want to fly as low as possible. So I think the lower the better, because you're gonna get a better picture of the ground. Now, the only drawback where I say it depends is the amount of space you're gonna be able to cover. Because remember, this track spacing is based on the camera's field of view. So the lower you get, it's like a flashlight. Imagine shining a fat flashlight down on the ground. The lower that flashlight light gets to the ground, the more narrow the focus. And that's kind of like the camera's field of view. So there's a give and take. The lower you get, now the track spacing is going to be a little more narrow. You're going to get a better picture of the ground, but you're going to make lot more passes, and you're going to be burning up that battery time, possibly covering a smaller area. So again, it depends. It depends on what the hazards are and the search area that you're searching in terms of your altitude.
Okay. I think we're going to come back to this a bit later on, because now we have one video that we filmed here near UgCS headquarters that we're going to kind of take a look at, and then we can comment that, and you can probably say maybe what we did wrong and what you would do differently in the search and rescue scenario, even in a training one. And also one note to the people who are listening to this, I saw one of you, I think, raised a hand, but maybe if you have any questions, you can leave them in the, there's like a Q&A kind of section where you can put all the questions that you have, and then we'll try and address them afterwards. All right, so maybe let's switch to the video, and then we can take a look at that. So let me quickly change the screen share. Okay, so I guess now you should be able to see the beginning of the video.
Yes.
Yeah, okay. Right, so let's start. So this is our field where we filmed everything, and over which we flew the search and rescue mission. And this is actually the same field that was shown in UgCS previously. And this is our sort of search dummy, the lost person. This drone we flew, so we flew the DJI Inspire 1. And here's the operator making sure that everything's correct with the route. And here, as you can see, this is the search mission. It's slightly different from the one that I showed in UgCS now, just because this was created on a different computer. But the basic idea is the same. So before the actual line, since we did not start at the very center, I just made a waypoint at the very beginning that would allow the Inspired to kind of fly up, reach a certain altitude, and then it would move towards the very center. And then from there, it would sort of expand, as already mentioned, and cover this whole area. And if some of you don't know this, then when you use DJI products with UgCS, which, and of course, you also support other drones, then we also have the Android app, which was also seen previously on the DJI remote controller. And you're also going to see sort of video from that was captured on this tablet. Okay, so first the mission is uploaded, and after upload, we press the auto mode to confirm and then confirm the command, and then send the drone on the mission. Okay, so after auto mode is initiated, you see the drone is taking off. And now it's going to begin its way to head towards the very center of the expanding square. Here you can actually already see the our sort of target, but of course, we know it's there, but it's just kind of there for demonstration purposes. So and this is the screen from the our Android app. So during the flight, this is actually what you are seeing here. Okay. In addition to, of course, seeing the UgCS screen on the laptop. And this flight was done at an altitude, as you can see in the top right-hand corner. The altitude was about 30 meters. So here now you have two screens. I'm sorry, I already skipped ahead a bit. You have two screens. So the video screen, which shows the video feed, as well as the small screen, which shows kind of where in the whole mission the drone is currently. So you can also switch between these two, just sort of monitor. And of course, you're also seeing the drone in UgCS. So again, there already on the side, you could see the person lying there. But when we flew in the sun, when you're looking at the tablet screen, it's even a bit harder to see that.
Sure.
But one good thing about, let's say, for example, this drone is that even when it's flying, you are still able to control the yaw. So you're able to turn the camera around, as well as to control the tilt of the camera, so you can look up or down using the remote controller. Okay, maybe let me skip ahead of it. Now here you can already see the target a lot better. So now what's done in UgCS, like let's say, as I mentioned earlier, you basically have two screens. One's the main laptop screen, and the other one's the tablet screen, which is sitting on the remote controller. So when you see some object in the video that you want to investigate, you can just simply press the hold command in UgCS, and that's gonna sort of pause the mission, and then you're gonna be able to control the drone. So you can either control the drone manually, or as is gonna be shown in this part, or in the next section, when the drone is gonna fly the creeping line, then I'm gonna use click and go command. Okay, so let's continue. So you can see here the hold command is initiated. So now it's showing that the route was put on hold. And now manually you can simply control the drone. And you can move the camera down to investigate what's the target. So here I'm just flying the drone over the target. See it a bit better, as well as since you're flying there, then in UgCS, if you place the mouse cursor, say, over the drone or over a certain area, then on the bottom left-hand corner of the screen, you can see the coordinates. And these coordinates can also be used, let's say, if you're flying a bigger area and you need specific coordinates and where, let's say, that person is, then you can use those. Or alternatively, I'm going to show that you can also place put place marks on the map. Yeah, so basically as shown here, you can right click and then select place mark. Then have various symbols loaded. And of course, in the case of missing person, you might not always want to use a place mark, but let's say if you use this for, say, other purposes that you also need to, fly over a certain area and maybe you find some dangerous elements there, you can still put these place marks just to kind of indicate yourself of where a certain object is. And now after, say you've marked this, now you can simply, if you want to continue the mission, you can press continue. Or alternatively, of course, you could just press return home to return the drone home, or simply perhaps land it in manual mode, whichever you prefer, depending on the situation. Okay, so now you can see that the drone is continuing on the mission. And yeah, so basically here it's gonna continue on the path. Okay, so let's skip maybe to the next part. So this is where we already landed the drone. And here we're switching from the expanding square to the creeping line mission. So we can hide one route and then just show the other one. And both of these routes, they were already created in the office before doing this flight. So of course, in some cases, when you're out in the field, you might want to modify them when you're out there. But it's still kind of good that you have this functionality that you can actually create this route when you're sitting in your office, for instance. And then when you're out there, you don't need to create it from scratch. You can just, let's say, change the location of the first waypoint and then just already start flying the mission. So that saves you time.
Yeah, can I jump in there real quick, Chris?
Yeah, of course.
Yeah, that's the beauty of this, is just the ease of creating these search patterns. Because really, in emergency response, you're kind of used to you're very familiar with your territories, so kind of like, hey, a call goes out, you're searching for a missing person in a certain location that you're very familiar with, so you kind of know the area, the altitudes, the hazards. You should be able to anticipate, hey, I'm going to search at 100 feet. For this missing person, and you can start, as you're responding to the call, programming and planning that search pattern. And it's so simple, because all you have to do is put in a search height, and UgCS does the rest. The polygon for the creeping line, or the last known position for the expanding square, and the search height, and UgCS maps out your search pattern. I mean, it's I fly the Bell 412 helicopter for the fire department, and it's this technology, which with UgCS is better than the stuff we have in the helicopter. So it's really impressive.
Well, maybe one day in the future we'll also add Bell helicopters to our list of supported vehicles.
Absolutely.
Hopefully. Okay, so maybe let's continue on here. Okay, so here you can see I'm just confirming that all the parameters are okay. So to those of you, if some of you are not familiar with UgCS, then on the left-hand corner of the screen, you always have the mission editor buttons, as well as the various fields which you can change. So for example, here you can change the flight speed, the turn type, the camera, but for the DJ Inspire, that's the Zen Muse camera, as well as the flight height, and of course the side overlap. And I think after we've done this video, we'll talk a bit more about those aspects and say which parameters should you choose for some specific search and rescue scenarios. So here I'm just slightly adjusting the direction angle. I made so that since our target is kind of closer to the drone, just for demonstration purposes, I made so that the drone will fly from the other side. So if you change the direction angle, then just it starts a creeping line mission from the other side. Okay, and now once everything is done, all you need to do is, here I'm removing the place mark. And then you can just press upload to upload the mission to the drone. And actually, one thing that you can do is, even when you're sitting in the office, you can actually still upload the mission. And then when you go out in the field, the mission is actually going to be on the tablet. So you're not going to have to open up the laptop and then sort of upload the mission again.
Excellent.
Okay, and now once the route has been uploaded, now you can simply click on auto mode. Then confirm the command, and then again, same as before, the drone is being sent off on the mission. So now it's taking off. Again, the altitude is the same, it's 13 meters. So now just it's going to move to the first waypoint that's always placed near the drone. And then it's going to fly over the field to the first point of the creeping line. So we can probably skip ahead a bit as it's flying. So here again, you have the tablet screen. As mentioned earlier, you have two screens. One is the main one for the video, and the other one is the one where you see all the waypoints. So if you, for example, would upload the mission say in your office, then you would already have all of these waypoints in the memory of the drone. So then all you need to do is go out in the field, basically start up the drone, then plug in the tablet, and then everything's going to be there. And all you need to do is just press auto mode and send the drone on the flight.
Excellent.
Okay, and I think here it's already on the the path where the target is. So again, as previously, hold command is initiated. So the drone is being put on hold. But here, earlier, if I can remind you, then in the first segment when we flew the expanding square, then I just manually flew the drone to the location. But in some cases, you might want to use the click and go command, which is basically that you can give the drone a single waypoint with a certain heading, and then you can make it fly there. So obviously, if the target is like very, very close, then yeah, maybe it makes sense just to use manual mode. But in some cases, when let's say the target is a bit further, then you might want to use click and go. So you just place the waypoint anywhere on the map. You can see in this menu, you can set the AJL altitude, the speed, as well as the heading. And the heading you can also, of course, set by just moving the arrow on the map. One thing I actually noticed when we were flying this was that, of course, when you're flying in manual mode, you can easily control the camera. But now, when I was flying towards the click and go waypoint, then the drone kept focusing on where the heading was set, because I didn't set the heading towards the target. I just kind of set it like somewhat randomly, so just like looking straight. So as I was flying, I could still control the yaw of the camera, basically. But it wanted to go back, so I controlled the camera one direction, and then it kind of pulled itself back. But after it reaches the click and go point, then you can again control the drone simply by using manual commands. Yeah, so here you can see it shows that the target point has been reached, and now simply manual mode. I'm kind of focusing the camera and finding the target. And here this is again UgCS screen, of course. And now same as before, you can just place the place mark there. And now basically I'm just flying the drone back in manual mode and landing it. So I think that's sort of it. That kind of covers the video. So maybe Tom, you can have some comments. Like, what did you think about it? Because as I mentioned, we're not search and rescue guys ourselves. You're the ones. So maybe what did we do wrong, and what would you do differently in like even like a kind of a training scenario like this?
Right. No, thanks, Christoph. That was a good demonstration. No, I think you're pretty much spot on. The only thing maybe I would change is set up a little slower search speed. I think you had 5 meters per second. You know, that's kind of difficult when you're staring at a screen looking for something. What I set up, and I think you know, we're on the imperial system over here. I put in 7.33 feet per second, which equals about 5 miles per hour. And another thing I noticed when I was practicing with this is that I went into I use Mavic Pro for teaching and stuff. But I noticed that I had to go into the default profile also of the Mavic Pro because, like you said, when I wanted to investigate something, I would hold and then I'd go to click and go. And if you didn't change the default profile settings to 7.33 feet per second also, the Mavic would move pretty fast at whatever and I think it was 16 some odd feet per second, which is a lot faster. So you kind of want to set all the default parameters up prior to starting the search pattern also, so that if you do click and go, it moves to that location at the same speed that it's in the search pattern, which again, I set it up at about 5 miles per hour, 7.33 feet per second.
I'm just now having some problems kind of translating the units. So like now on a different screen, I'm kind of like Googling 7.33 feet to meters. So those our listeners who are from Europe, that's about the 7.33 feet. That's about 2.23 meters. So in this case, it's meters per second.
Correct. That sounds about right. And another thing I noticed was a side overlap was up to 30%.
Yeah.
I would typically set my side overlap to about 10%, especially in a field where you're not dealing with too many potential altitude variations. Again, UgCS does an excellent job maintaining the aircraft's altitude at the altitude you set or prior when you were planning the mission. Now, there's going to be minor deviations, obviously, in the AGL and the altitude, and that affects your overlap. That's where the overlap comes in. But I think in your case, probably 10% would have done relatively well, because with the 10% overlap, your track spacing is going to be a little greater, so you're going to be able to cover a little more search area given your battery supply.
Right, so here I can actually probably demonstrate that. As you mentioned, the default value, that's 10. But just like when we flew, I wasn't really sure what's the perfect side overlap in these cases. So I can just kind of demonstrate, like if you switch to 30%. Yeah, so you can see that the track spacing is a lot, basically, they're a lot closer to one another. And now if you switch it back to...
I think in your side overlap...
Oh, sorry, yeah, sorry. Yeah, so this is 30, and if you switch it to 10, yeah, now you can see this is a lot further away. So I guess the main reason for doing this is to save battery, so you can cover more area in a single flight.
Exactly.
I presume.
Exactly.
And say you mentioned that you use 10% when flying above field like this. But right. Let's say if you would be flying above forest or maybe some other areas, how would that be different? And how would you decide what side overlap would be best used in this scenario?
Well, I think it all depends on the terrain, the differences in the slope in the terrain. So I think the greater the differences in the slope, you would probably use a little greater side overlap just to account for the difference in altitude between the camera's field of view and the terrain elevation. So I'd probably use, like you did, Christoph's, about 30% if you were in heavily forested, heavily sloping terrain. And I would also slow the search speed way down also. And then again, you get into what's your best payload? What's your best sensor payload? I mean, if you're going to be searching a heavily forested area, you're going to want a thermal payload if you have that capability instead of an optical.
Yeah, of course. And also, so let's say about the flight height. So what would, let's say when flying above the field, because in this case I said about 30, but would you do the same, or would you kind of do it a bit differently?
I think 30 is fine. 30 meters is about what is that, about 90 some odd feet, almost 100 feet.
Yeah, it's about 100 feet.
No, that's what I would do. I usually if I can search at 100 feet, that's where I'm searching at. That seems to be the best altitude with respect to track spacing and battery life.
And so another question: what's the approximate area that you would try to scan? Would you kind of try to max out each battery, or basically would you have one area and then fly with one battery and then just like scan another area, or would you like mark a huge area, and then since UgCS has this battery changing feature, would you simply fly one big like area scan, and I mean, like in this case that would be creeping line, and then just like change the battery in the middle?
I think again it depends on the scale of the event. If you have multiple drones in the area, again, that's why UgCS is so great. Is you could have an incident commander set up search sectors for each drone. So then it depends, so it would depend on the incident commander's discretion. If you were the only drone there, because obviously with multiple drones searching at the same time, you're going to search the area quicker. But if you're the only drone available, then I would, and you have multiple batteries, then just start and try to search the whole thing with the battery changeout feature that UgCS offers.
I think maybe it's also good at this point that we can mention that one feature that UgCS has for this search and rescue functionality is that this whole software is made so that it has multi-node deployment, which basically means that you could have like a command center setup, which means that you can have like one central station that, let's say when you have, for example, like 3 or 5 drones flying and searching, let's say for a missing person, then you can have one central command center where a person is monitoring what each drone is doing. And you could have all of those drones connect to that single kind of command center and also show the video streams from each of the drones.
Yeah, that's an excellent capability.
Okay, so yeah, again, this is the briefing line. Maybe it's also the expanding square here. Do you have any more comments, or maybe we can see if there are any questions, or maybe someone wants to, because I see some people raise the hand there, so I guess they want to ask something. Oh, one question I have is, well, typically, do you fly missions that have terrain following, or do you fly missions that just are kind of at a single straight line, and I mean at the same altitude above median sea level?
Well, typically here in South Florida, yes, mainly the same altitude. We don't have to be too concerned about terrain following, just because everything's, it's pretty much, I live in the Everglades, so it's pretty flat out here, fortunately.
But I suppose if you would fly a search and rescue mission in a more kind of mountainous area, you'd probably use terrain following. Am I right?
Absolutely. Yes, correct.
Okay. Because another feature that UgCS has is that if you don't have the terrain data for a certain location, you can actually import that data into UgCS, which is something that many other mission planning softwares don't really have.
Yeah, that's an excellent feature.
As well as there's that, and of course, we also have map import. So for example, if you would fly, if you maybe didn't have accurate maps of a certain area, so maybe now it would have more forestation, then you could fly one, so let's say in the area scan mission, or photogrammetry mission that would cover that whole area. And then you can actually stitch the images together and just import them back here. So to have a more accurate map that you could later use for mission planning.
And that just to ask you a question, Christoph, that area scan is real time, right? You can stitch it. What do you recommend? Is that, so that's not cloud-based. So I show up at a scene. My wife is a search team manager for Florida Task Force 1. So, you know, a large scale disaster that could come in really, really handy where they can stitch together. Because, you know, you think about drone deploy or Pix 4D, you know, you're waiting overnight possibly to get your map back. So that area scan, can you talk a little bit more about that?
Yeah, sure. Okay, here we have two routes. Let me just quickly just add the route so I can better demonstrate how that would work. So, but in essence, the area scan route in a way it's similar to the creeping line that's shown there. So let's quickly create an area scan mission. So it's AGL. Let's set the flight height to say 20 meters. So distance the same. So the main thing is you need to mark a certain area. Let's just take this area, for example. Then the mission's automatically calculated. And then as the drone would fly, it would take pictures, because you can add these kind of camera actions. Or if you use photogrammetry tool, that's actually already taking into account what camera is the drone equipped with. And then that would simply use those parameters when calculating that mission. And after the mission is flown, then you can simply take all the images from the memory card of the drone's camera. You can take it back to your laptop, and UgCS installation, it comes with UgCS Mapper software, which basically you can just select the folder where all the images are, and then it's going to automatically stitch them together. And the whole process, let's say for an area like this, I think it would take around 10 minutes or so. Of course, it depends on the area and the amount of pictures, but certainly it's not that you need to leave the computer there overnight. I mean, sure, image processing, it takes some time depending on what processor do you have and, you know, how capable is your computer. But if you have a fast enough laptop, it can take like minutes, not hours.
Yeah, that's a great feature to have.
All right, now maybe let's see if we have some questions. Okay, so there's, okay, so Jeff Hughes is asking, hello, and thank you for this information. I understand he's from Arizona, and so many cities are adding drones to their response equipment. So how well would this work near a cliff face or in a valley setting? Maybe I can try and first answer this question. Well, since you would probably need to use missions with terrain following, then what you could do is that you could see if first, like just with your eyes, you could judge how accurate the elevation data is. Like, let's say if you see a cliff in front and also in the map, let's say when you zoom in, you would also see sort of like the map slopes down, then that might be kind of more or less accurate. But in some cases, the area will appear flat on the map, but the cliff will be there. For example, when, let's say a mining quarry has been dug, right? And then the actual elevation differs from the one that's in the map. So in that case, yeah, of course you can use terrain, I mean, digital elevation models, which you could import into UgCS, and then using those, you'd have more accurate data. And maybe Tom, you could comment a bit about, like, if you would have to use, if you have to fly search and rescue missions with a drone in sort of like a valley setting, or in although we can cover this, but maybe you can still add something more. If you would fly search and rescue missions in an area that has kind of some terrain, like some larger changes in terrain, let's say here. So what would be the main things that you would take into account when planning your missions?
Well, obviously, I take into account the sensor capability on the aircraft. You know, the front obstacle, or just the obstacle sensors on the different aircraft out there. Second, I would probably um, develop search patterns, maybe possibly smaller search patterns in the valley areas and the smaller areas, so that you could kind of work your way up the valley, so to speak, or up the side of the mountain, so that you're kind of searching sector by sector, to where you kind of eliminate that that hazard or that risk of the different terrain. Is a second thing I do. And then obviously the terrain following feature of UgCS is key.
Okay, thank you. And so let's see some other questions that we have. So which one should we answer? Chris is asking, what overlap is needed to stitch the imagery together in the expanding square case into Arco for ICS planning? Well, I mean, technically, I think in the expanding square, you could also add camera actions. So if you're flying it and you set, because Tom, you mentioned that overlap you would use in for search and rescue missions, when simply just looking at the video feed from the drone, that would be like 10%.
That's what I would use, yes.
Yeah. But
now, obviously, if you're going to stitch together pictures, probably the more overlap, the most overlap you can get, the better, you know?
Yeah.
With the accurate.
So for that, of course, you have to plan how much battery do you have in your drone.
Exactly. That's the trade-off, you know?
Yeah. So maybe like from our experience, I think 30% would be okay. Maybe, of course, if you can go higher, that would be better. But then, of course, your flight time that you would have to that you would need to use to fly the mission, that would decrease. Okay, let's see what else. Okay, so Greg's asking, do you require a laptop to run the program? Can I operate from just an iPad? Currently, unfortunately, we don't yet support iOS devices, although hopefully soon we will. But if you have like an Android tablet, then as already mentioned earlier, what you could do is that you could plan the mission in the, let's say in the office, or just like whatever place is convenient for you. And then you could upload that to the tablet. And then when you're out in the field, then you can just simply like plug the drone's remote controller into the tablet, and then you can fly. Okay, so Scott has a question, what vehicles are supported? Is Unique Typhoon Pro supported? Currently, from Unique, we are supporting the H520. But regarding other drones, we support most DJI drones, as well as we support Ardocopter drones and some others. So let's say if you have a specific drone that you want to use with UgCS, then support for that can be developed. So if you want to get in touch with us, you can just simply write an email to ugcs@ugcs.com, and then we can talk further. So Don Phelps is asking, is there a feature to allow you to land during the mission and change the batteries and then continue the mission where you left off? So maybe I can quickly just show this feature. So the answer is yes, we have that, which is also, I guess, it's useful in search and rescue scenarios. So maybe let me take the creeping line example. Let's first hide the other ones. And here I have the creeping line mission. So currently the mission as it is, you would be able to fly that with a single battery. But if I say wanted to scan a larger area, like so, I hope we're going to have enough radius in the profile of the drone. Okay, so I need to change that. Okay, just to answer this question, let's get rid of this error message. You could also change this in the profile of the drone, because each drone has a specified maximum altitude from starting point, but you can simply change that. But let's say in this example, if you say if for some reason you started to fly with a battery that was already quite low, and say you went to the, let's say the 7th waypoint, and you saw your battery was critically low and you had to land, and then you wanted to restart this mission from this waypoint, then what you could do is that you can click here in the, because basically here we have the drone cards, and here we have the route cards. So you can click here on the parameters, and here you can click on change starting point. And so here you could simply, plus here you can see there's a flag. And so if you would upload this mission to a drone now, then the drone wouldn't fly this whole sort of area. It would fly to the first waypoint and then simply fly here, and then just basically continue the mission from this point. So another question, will the link be by email? Well, yeah, basically this whole webinar video, it's going to be available on YouTube, so you'll be able to rewatch it later on. Okay, I think we answered most of the questions that we have here in the Q&A. So maybe before we kind of end everything, Tom, maybe you can kind of tell a bit about, say, your vision of what you would see the future of drone applications in search and rescue, and say, how do you think that the industry is going to develop? Your microphone's turned off.
Sorry about that, Christoph. So yeah, the big is beyond visual line of sight. But before we get there, probably my vision is machine learning, real time, as the smaller processors get faster and faster, and you're able to process more and more information on these flight computers on the drones. Machine learning is probably what I see as the nearest when you in terms of what's coming in the horizon. If you can teach, create an algorithm that you teach a computer to learn what the color blue, like most people when they go out hiking, or they go out in the woods, they're wearing the blue jeans, so if you could teach a computer to spot that color and look in the field or in the forest and pick up even just one pixel of that color and teach it to stop there, mark it, real time. I think that's got a lot of potential in the near term. Teaching a machine to recognize certain portions of the human anatomy, maybe you fly over something and somebody's taking a break, or they're unconscious underneath a tree, and maybe all you see is their foot, and it's too small for the human eye in the video, but you have machine learning, and it stops and it says, hey, there's something there that needs to be investigated. That just off the top of my head, that's where I think it's going.
And do you see, say some sort of more automation coming in manned aviation, or do you think that, say, manned aviation would still be used as it is now in search and rescue, or maybe there would be some more, say, software control, or let's say, of course, like these drones that we're talking about now, most of them, they use simple batteries, but maybe some to. Because that's your main limitation, right? So if you wanted to fly, let's say, over this whole field, you'd need to have multiple batteries. Maybe for, say, search and rescue operations, it in some cases might be better to use drones with, let's say, internal combustion engines that would be able to fly over larger areas.
Absolutely, that's fuel is always a limiting factor. Fuel in terms of battery life, or internal combustion, jet fuel, avgas. So yeah, absolutely. I'm not sure, but I'm sure there's probably hybrid drones being developed, battery and combustion engine type systems out there. So that would be something to look forward to also.
All right, and now let me see. I think we've covered most of the ground that we wanted to cover here. So I think for the most part, that's it, because I don't see any kind of new questions coming up. I think we answered all of them. Again, Tom, I'm going to say thank you for joining. Thank you for kind of, I'd say, expand this like search and rescue field into drone mission planning. Because probably if you guys hadn't come up to us at the Exponential Expo, then now probably wouldn't be here. And these actions, like these mission planning tools wouldn't be implemented here.
Right, yeah. And Christoph, I challenge everybody listening to see if they can find anything out there. I think UgCS is the only mission planning platform out there that offers these search and rescue patterns. And it's really exciting stuff. And it's going to make the public safety industry that much easier to work in with drones.
Sure. So, all right, I guess one more time, thank you. And I think that's the end of this webinar. So looking forward to maybe participating with you in some future webinars.
Absolutely. Thanks, Christoph.
Yeah, all right, thank you.
Take care.